Hey guys, what's up? Today, what we're going to be doing is we're going to be covering graphing, and more specifically, we're going to be recapping how to do table graphing and also how to do some quick graphing. So, a little bit of a shortcut to quick graphing. It is very important that you know both. Quick graphing is by definition and by the way we say it, a little bit quicker than table graphing, and it's a shortcut that you guys can use in order to make graphing a little bit easier. However, table graphing is very important because it teaches you the concept of graphing, and there's certain times where quick graphing does tend to trip you up because there are a few things or rules that you need to have before you can do quick graphing. So to start it all off, what we're going to be doing is we're going to have our PowerPoint as always. We're going to run through it. What I'm going to be doing though is if you're already good at table graphing, I'm just going to put a timestamp in the description where you can jump straight to whatever the quick graphing time will start. So then you guys can start straight from there. Okay, so let's get started. As a quick review, when we're talking about graphing, what we're saying is it's a visual representation of all possible answers to an equation. All right, it's a visual representation of all possible answers to an equation. And when we said answers, what we meant was that there's an x component and a y component. So if I have something like this, y equals 2x, what we're saying is that any y we pick has to be equal to 2 of our x's. So if I were to have something like this, 3 comma 6, this is a possible solution because what we're saying is that when x is 3, my y value is going to be 6. And that fits my pattern that y is equal to 2 of my x's. Another possibility we have is something like 0 comma 0 because 0 is equal to double 0, right? That's totally fine. You can use fractions, any number you want. You can use a million, a trillion. It doesn't matter what number you're using, but as long as you're saying whatever x you're choosing, my y must be doubled, those are a solution. And because of that, there are infinitely many solutions. So what a graph does is it visually shows you all of your possibilities. So let's just do this really quickly. Let's use the ones we have. We have 0, 0. That's right here. This first number here, this is my x. My second number here, this is my y. And what we're doing is my x tells me how much left and right to go on my graph. My y tells me how much up and down to go. So when we're doing 3 comma 6, what we're going to say is we have 3 to the right and 6 up. That's going to put us right here. We went 3 to the right and 6 up. Now, these are 2 of our solutions, and when we're graphing lines, what we said is to graph any line, you just need 2 points, and then after that, what you can do is you can just draw a line through it, and we'll say, hey, basically we're going to continue this pattern over here. If I can actually make it go through, come on. Nailed it. But basically that's what's going on here. We're saying, hey, this line here represents all of our possible solutions. Now what we're doing though is we're going to put an arrow on the ends of these because what we're saying is the solutions don't stop here. They continue on. So if I were to take something like this, 1 comma 2, this is also a solution because what it says is that my x is 1, my y is double. So again, that's kind of how we're graphing. We just get all of our solutions, put it down. Now, when we started this, what we said is in order to graph, we need 2 points or solutions from your equation. And the way we find those points is you use any x and find its matching y. So just pick any x you want, plug it into the equation, and find the y. So let's do a super quick example on that. So if I give you this equation here and I said 3x plus 2y is equal to 5, then what I want you to do is I want you to graph this using a table. So what I'm going to be doing is we're going to be setting this up. X, y, so pick any x you want. So in general, I said you're always going to pick 0 and 1. It's always a good idea. So if x is 0, then what we're going to get is 3 times 0 plus 2y equals 5. And then that means 2y equals 5, which means y equals 5 over 2. Now, 5 over 2 isn't the nicest thing in the world, but we know it's about 2.5 or a little bit between 2 and 3. So we just plug that in, 5 over 2. And our coordinate form is 0 comma 5 over 2. So then we just graph that out. Now again, my first number tells me how much left and right to move, so I'm stuck here at 0. And then our second number tells me how much up down to move, and we said that's just between 2 and 3, so that's going to be right here. Now when we plug in 1, let's figure out what our next point is going to be. 3 times 1 plus 2y equals 5. So then we're going to have 3 plus 2y equals 5. So 2y equals 2 and y equals 1. That means when x is 1, y also happens to be 1. So that's going to be this point right over here. And again, just like before, what we're going to do is we're going to get our line and we're going to draw it through the first time. And then just put our little arrows at the end. And that's it. That's how we draw our lines using 2 points. Now, one of the things that we said is you can pick any 2 points you want. In general, I pick 0 and 1 almost every single time, but there are certain cases where we're dealing with fractions and it's not the most fun thing in the world to multiply fractions. So one of the things that I said is there are certain points that are better than other points. So when we're dealing with something like this, we know that y is equal to 3 over 2x plus 1. So of course, I always pick 0. So I'm going to pick y equals 3 over 2 times by 0 plus 1. That means y equals 1. And then we have 0, comma 1. Now, if you notice, I'm not doing this with the table. You can do this with a table. I'm not, because I, again, told you there are multiple ways that you could do this as long as you either have a table or ordered pairs. I'm totally fine with that. So I'm just showing you different ways that you can do this. But you can totally set this up in a table if that helps you. But one of the things that we don't want to deal with is this fraction. And what we said is fraction is just unfinished division. So when we have y equals 3 over 2, what we're saying is we're taking 3 divided by 2. And the way we undo that is to multiply by 2. So instead of picking 1, this time I'm going to pick 2. So that way I have y equals 3 over 2 times by 2 plus 1. And then my 2's undo each other because I'm dividing, then multiplying by 2. They undo each other, so they get rid of each other. So then we're left with y equals 3 plus 1. So y equals 4. And again, my point is going to be 2, comma 4. And the way I get that is, again, this first number, that's the x I chose. My second number is the y that I got from it. So now, putting it together, we have 0, comma 1 here, and 2, comma 4. It's right here. And then we just draw our line through them. And then, of course, as always, we put our arrows. That's it. So this is how you guys are going to be graphing. You guys should have done this already. We already did one worksheet on this. So if you guys are having trouble with the worksheet, that's kind of how you're doing it. There was a couple of special cases. One of our special cases is if we only have an x or we only have a y, and the same kind of rules apply. We're just saying, okay, what do we know? What are our solutions? Now what this is saying is my x is negative 3. Doesn't care what y is, it just says x must be negative 3. So y can be 5, y can be 6, y can be 12. But if x is 3 or negative 3, doesn't matter what y is, y could be 0. X is negative 3, doesn't matter what y is, y could be 1. But we're just fitting the pattern. Just like before when we said y is equal to double my x's, we're saying here, I don't care what y is, all I care is that x is negative 3. So if I plot these three out, we have negative 3, comma 0, negative 3, comma 1. It just so happens we can draw our vertical line through it. Now, if you remember the rule that when we have just x equals, it's a vertical line, and y equals, it's a horizontal line, that's fine. But if you ever forget, just think, what is graphing? All graphing does is it tells me what is the pattern that I'm trying to follow. Okay? All right, moving on. Now, this is where we're going to get into quick graphing. Now, what quick graphing does is it takes what we know about slopes, points, and lines and puts them all together. So let's just do a quick review of what we know so far. So we know that slope is rate of change. It shows how x and y grow together. For example, if I have something like m is equal to 3 over 2 and m is our variable for slope, what we're saying is that I rise 3 and I run 2. Or another way that we said it is that my y changes 3 when my x changes 2. What this is telling me is that for every 3 I go up, I have to go 2 to my right. Okay? That's basically what's going on. It says for every 3 I go up, I have to go 2 to my right. So with that in mind, we're going to be using this, but I just wanted to remind you guys there were 2 types of equations that we have been working with so far. This first one up here is y equals mx plus b. This is the one that a lot of you guys were familiar with earlier. This is your slope-intercept form. The number in front of your x, that was your slope, and your constant, your number all by itself, that was your y-intercept. Point slope form is the same thing. It says my x1 and my y1, those are the coordinates of your point, and your slope is your m. So again, slope intercept gives you an intercept and a slope. Point slope gives you a point and a slope, hence why we use those names. So we're going to pull this all together and we're going to show you how to do a really quick example of quick graphing. So this is our shortcut method. Basically, this form here is slope intercept form. So what we know is my slope is equal to 3 over 2. and my y-intercept is equal to -2. Now, if you guys remember what an intercept is that's where my line crosses my x-axis or my y-axis. So I'm going to minus myself down so that way you guys can see the graph a little clearer. What we're going to do is we're going to say this here tells me one of my points. It says that my y-intercept is -2. That gives me a point right there. This is one of my points. Now, in order to graph, we need 2 points. So what we're going to do is we're going to use our slope. And what our slope says is that from this point, I can find another solution as long as I rise 3 and run 2. So we're going to show that. We're going to go up 1, 2, 3 to 1, and then we're going to go to the right 1, 2. Because what it says is that if I go up 3, I have to go to the right 2. And that's where we find our second point here. And again, in order to graph a line, we just need 2 points. So all we do is we have these 2 points, then we just draw a perfectly drawn line through both. That's how we draw it. This is the shortcut method. You just put one of your points down, then you use your slope to find your second point. Again, your slope tells you how much does my y go up when my x goes to the right this much. Now, if you notice, both of these numbers were positive. If I have a positive number, I go up. If I have a negative number in my numerator, I have to go down. Same with my denominator. If it's positive, I go to the right. Negative, I go to the left. So let's try another one really quickly. Now this one isn't in slope-intercept anymore. This is in point-slope. So since it's in point-slope, what we're going to be doing is we're going to be saying, what is our slope first? So let's write that out. M equals 2 over 3. And then what is the point that I'm given? My point is -1, 3. Now the reason it's -1 is, remember what we said when we're taking points, it's always the opposite. Since this is supposed to be negative, if it's positive, that means my x is negative. So now we have our point, we have our slope. In order to graph a line, we need 2 points. So let's put our first point down. -1, 3. That's this point right here. Then in order to find this, my next point, we use the slope. It says we rise 2 and run 3. So I'll give you guys a second. If you guys are following along, try to think what's going to happen here. So from here, what we're going to do is we're going to go up 1, 2, and to the right 1, 2, 3, and that's going to drop us off right here. Then we're going to draw our line through. Oops, excuse me. And then as always, little arrows. That's it. So again, all we're going to be doing is we're just going to say, hey, let's use what we know. We need 2 points. I get my first point by looking at my equation, and then my second point, I'm just going to use my slope. It tells me how to move in order to find a second slope. So again, my numerator, that tells me how much up, down to go. My denominator, that tells me how much left, right to go. Now, just as a quick note, these here are not necessary. You can totally just draw it like this. That's fine. But for this current homework, I am going to ask you to put this down so that way I can see your work. It's a quick way to show work. And what would be even better is if you just label it 2 and 3. So that way it kind of helps you remember, okay, this is how I'm moving. Again, this is the shortcut method. No tables, no plugging in, no worrying about adding and subtracting correctly. However, if you noticed, they're only in these 2 special forms, point slope and slope intercept. If it's not in those forms, you either have to make it into one of those forms or you're going to have to use the table method, which is why it's very important to use the table method because that one always works. This one has a few rules attached to it. All right, last one over here. Let's kind of look at this. So again, this is in slope intercept form. So what we know is my m is equal to 3. My y-intercept is equal to 1. Now, from here, we just put our first point down here. And then after that, we need to use our slope. But our slope isn't in a fraction form. So we don't know what our rise is. We don't know what our run is. But what you do know is that we can turn any number into a fraction by just putting it over 1. So this is the same thing as saying 3 over 1. So that means from this point, I have to rise 1, 2, 3. And then I have to run 1. And this is how I get my second point. Then from here, we just, whoops. I am so bad at drawing lines. Connect the dots. That's it. Okay. Now, If I give you something like this, like I said, since it's not in point slope form, it's not in slope intercept, unfortunately, we're just going to have to use our table method. There are ways that you can change this into slope intercept form. I've gone over it before a little bit, but if you're having trouble, you don't remember, tell you what, just jump back to the table method. It's probably going to be quicker at that point. So on your homework today, what I would like you to do is I would like you to graph all of your problems using this shortcut method. But I want you to show your steps. Like I said, once you get used to it, you don't need to. But for now, because I want to test to make sure that you guys know what you're doing, I want you to show these little bunny hop lines that I drew over here and here, so that way I can tell what you guys are doing. If you have any questions, as always, feel free to reach out, remind or email or anything like that. But yeah, also make sure to check out for the sign-up sheets on the Google Classroom for tutorial time. So if you know you're struggling with graphing, make sure you get help, so that way when we move on next week, we're going to be making sure that you guys are really good with graphing, and then we're going to actually use that for something else. So if you have any questions, feel free to let me know. Again, shortcut method is very good to use because we are going to graph, and if you're constantly just plugging in numbers into a table, it's just going to take forever. So again, try this out. Let me know if you have any questions, and I'll see you guys next time.